Hello and welcome. If you're just now coming to this video is part of a long series on custom named entity recognition for digital humanities, all in Python and spaCy from the ground up. This video is going to deal kind of with a end-to-end flow from idea to development for developing a Latin named entity recognition statistical model using spaCy. So we're going to do this from the ground up all the way through. I'm going to throw in some intentional mistakes along the way. I'm going to introduce some unclean data along the way so that you can see how to address real world problems that come up when designing a named entity recognition model. Now, this is going to be based around classical Latin with the idea for a future video in which we bring in some medieval Latin. We're going to see the weaknesses of using classical Latin NER on medieval Latin texts at the end of the video. But even if you don't understand Latin, if you don't know Latin, I am not going to presume that knowledge in this video. I'm going to presume that you are interested in learning and working with non-English NER or highly inflected languages NER or NER for extinct languages, languages that are not currently spoken, or those who say that they are by a very small number of people. So let's go ahead and jump right into what we're going to be dealing with. Our goal in this video is to get a spaCy ML model to recognize 3 different entities in Latin texts. People, so person tag, locations, so the location tag, and groups. Now I'm defining groups very generally here. These are going to be groups of individuals, so tribes that we find in Gaul, Trojans as a group of people, Romans as a group of people. So I don't want to use the word ethnic group because I think ethnic adds a little layer of complexity that's not necessary here. Just think of group as groups of individuals and defined by how Romans would have perceived not ethnicity, but groupings of individuals. Hopefully that makes sense, and hopefully that avoids a lot of the methodological pitfalls of introducing things like ethnicity. And what we're going to do here is we're going to be working with a few different pieces of data. I'm going to walk you through, give you the functions, and show you how to write the functions for doing all of these steps along the way. Our first goal, this is going to be straight up copying and pasting. We're going to work with Caesar's Gallic Wars, and by the end of the video, we're also going to be throwing in his Civil War as well. And we're going to be using this corpus to automatically annotate so that we can actually have a good named entity recognition entity ruler to then cultivate a really good training set of around 500 chapter annotations of people, locations, and groups. Then what we're going to do is we're going to do all that by using a set of data that we're going to acquire from Wikipedia for persons. We're going to use the Orbis Latinus, a very handy resource. We're going to be seeing all of these, and Latin place names, another handy Latin resource to get locations. And then we're going to use Wikipedia and do some manual additions to kind of get a good data set for classical groups of people. So entities such as Romans, Etruscans, etc. So let's go ahead and just jump right in. What we're going to do is we're going to start off by just making a main.py script. I'm walking in from the very beginning to setting up the entire structure. The other thing I know that we're going to have, and this is always good practice, is I'm going to have a data folder. So add in a data folder. And all this is going to be on the GitHub so you can kind of follow along. Now, the first thing I need to do is I need to think about acquiring the data necessary for annotating. So let's go ahead and have a file. We're going to call this right now just corpus.txt. And this corpus.txt is going to be is going to come from the Latin library. So I'm going to pull it up on this screen over here and drag it over. The Latin library is a great resource. It's all available. It's open source, and it lets people that are doing NLP or just trying to improve their Latin really have really easy to copy and paste Latin. And so what we're going to do is we're going to work with Caesar. If you saw, I just clicked Caesar right here. And you can see that you have 3 different collections of texts. His the Gallic Wars, you've got the Civil War, and then you've also got some other books of uncertain authors, it looks like. So what we're going to be doing is we're going to be working with, for right now, books 1 through 8 of the Gallic Wars. And then we're going to, in the middle of this video, you're going to see why I do this in 2 different steps. We're going to start adding in some extra data, and that's going to come from Caesar's Civil Wars. And this is all going to be part of the trial and error process. Now, I've done a lot of the trial and error already, so I know what's going to work, I know it's going to work, but I want to walk you through all the steps that I took to do this. So all I did was just select all of this, and I copied and pasted it into a corpus.txt. I'm going to move this over here, and I'm not going to make you sit down and watch me copy and paste everything over. So I'm going to go ahead and just copy it from the pre-prepared data that I already have. So I'm going to copy in my corpus right now. I'm replacing it, and now we see it all populated here. So the first are all 8 books of Caesar's Gallic Wars. And it's the opening line that everyone has to memorize when they start doing Latin: Gallia est omnis divisa in partes tres, right? All of Gaul is divided into 3 parts, and then it goes through and tells you the different peoples that live in those 3 different parts. So the Belgae, the Belgians, which is where we get the modern name for Belgium, I presume. I'm pretty sure that's right. The Aquitani, this is still a region in Europe today, and the people who speak the language of the Celts. So the Celtic peoples, which are called the Gauls in the Roman language, Latin. So that's what we're going to be working with as our baseline corpus for the earlier parts of this video. Now, the next goal is we need to also not just have a corpus to annotate, we need to have the data sets necessary for automating that annotation. Now, if you looked at the earlier videos in the series when we worked with Harry Potter or Holocaust, we had to get a little creative in how we cultivated these data sets. No 2 data sets are alike, and creating data sets is going to be a unique challenge with each different domain or workflow that you're working on. So what we're going to be doing is we're going to be working with a few different web scraping libraries, specifically requests and Beautiful Soup in Python, to get the data necessary for acquiring all these names. And a really good place to start off with acquiring data sets or finding ways to scrape data sets is Wikipedia. And that's true for the for modern NER, and that's also true for Latin NER. What do I mean by that? Well, Latin names have 3 different forms. They have a praenomen, the name that comes first. This is often a personal name, followed by the nomen. This will be the family name, and then followed by the cognomen. This is like a second personal name. So you'll have 3 different names for Roman Latin speakers in texts. Oftentimes, the praenomen will be, as we'll see in this video, abbreviated. So L period, M period for Marcus, I believe is what M period is. But they also exist in their full form. So a praenomen could be Marcus, or simply M for short. And these both appear in, M period for short. These both appear in classical texts. So our goal is to account for all that and make sure all praenomens, regardless of their form, are introduced into the entity ruler. The other thing that we have to think about, and this is why I encourage those not familiar with Latin to watch this video, is Latin is a highly inflected language. What does that mean? It means that every name is going to decline X amount of ways. Depending on its declension, it's going to decline in different ways. This tells the reader of the language what part of speech that word has. So Marcus would be, of course, the if you're familiar with Latin, the nominative singular, right? The subject of the sentence. Marcum will be the accusative or the object of the sentence, and you can keep on going on down the list. If you're watching this video, chances are, and you know Latin, chances are you already know how to decline your basic first, second, and third declensions, and that's what we're going to be working with also in this video, is figuring out a way to take the root names, and I'm going to show you how to do this. Use Python to automatically decline things. This is going to be a fun little challenge that I've already worked out, and I'm going to share with you on GitHub and work you through all that right now. So let's jump right in, and let's try to start gathering our data. I'm going to change this from main right now, and I'm going to make just a temporary folder where I'm going to drop all my temp functions. And I'm going to add a temp function in here called wikascrape. I'm going to call it wikascrape.py. That sounds like a good name. This script is going to have a couple different functions. Its entire idea is to go to Wikipedia and get the data necessary. So the first thing I'm going to have it do is I'm going to have it go to Wikipedia, and I'm going to provide this link and everything in the description down below. And it's going to go in and it's going to grab all of these nomina. These are the names, names for Latin authors. This is going to be the family, so the Julian family, etc., on down the list. As you can see, we have quite a bit. Now, if you're not a fan of Python, you'd have to copy and paste. But if you're watching this video, hopefully you're a fan of Python, and we're going to just simply write a few functions to web scrape this page and get all of these names nice and easily for us. So I'm going to push it to the side. I'm not going to walk through all of the different elements of these functions. I'm going to kind of just get them out there real fast. In fact, I'm just going to copy and paste them over. I'm going to share them. I'm going to have an entirely separate video on how to do proper web scraping in Python. So we're going to import a few libraries. We're going to import requests. We're going to say from BS4, and we're going to import Beautiful Soup. And then what we're also going to do is we're going to do what I always like to do whenever I'm doing something. I'm going to bust out my handy dandy Stream Deck and just cheat and have it write all those things for me. And that's going to be my basic functions for loading in and writing JSON data and Python. And I'm going to copy and paste over my functions for gathering the data necessary. So here's a function for getting just the nomina page of Wikipedia, so the Roman nomina. It's already written for you. What it does, real quickly, just going through it, is it grabs the URL, goes through Beautiful Soup and requests, opens up a blank list, and then it goes through and finds all of the sections in the page. So it'll find, if you look at the page, you have the A section, the B section, etc. It goes down, it finds all those sections. I think there's 9 of them. And then what it does is it goes by each section and finds all the items that are listed there. And then it goes through and rips them out. And so it just grabs essentially only this name right here. That's all it's doing. Nothing fancy, basic web scraping. Again, I've got videos on web scraping. I'm going to record some new ones because they weren't my best work. But let's go ahead and just leave that as is for right now. In fact, let's go ahead and just kind of demonstrate how this is going to work. So I'm going to run get underscore nomina, and what it's going to do is it's going to drop all the nomina into a JSON file in my data subfolder. And if I run that, everything should run nice and handily, and in fact it does. You saw the file get created, and we go down the list, and we've got, how many do we have? We've got 542 nomina. Fantastic. Now, this is not going to be a perfect list right now. I've got a perfect list that's dropped in on GitHub, but I want you to stick around and watch some of the problems that are going to occur with this list and how we rectify them. The next thing we need to get is we need to get all of the cognomina, right? The other names that come after the praenomina, or sorry, that come after the nomina. And this is going to go to a different Wikipedia page, also in the description down below. As you can tell, this is a different list. So this is all the different potential names that might come up in a Latin text. So you can see there's quite a bit. So what we're going to do is we're going to run this script. So we're going to, now we don't need to run get nomina again. We're going to say get cognomina. We're going to run that. And this is going to now grab all the cognomina for us. As you can see, we'll go down the list and we've got, quite a bit. We've got 1,732 different names. Fantastic. I'm very happy with that. And now we're going to do the final nomina. This is going to be a little bit more of a cumbersome task to get all the praenomina. So what we're going to do is we're going to copy this entire function over. And this one's a little bit clunky. Not clunky in the sense that it doesn't work, clunky in the sense that it's unnecessarily long. I did a couple things. Bottom line, it works. What this function does, it has to get a little bit more creative. So the praenomina I've got stored in a separate text file, which I'm going to copy and paste over in just a second. I got them from this page by simply going over and just copying and pasting all these in. I did that because in this case, I was working with a finite amount of data, and it was easier to just copy and paste it into a text file and then be happy. If you notice on this Wikipedia page, it's got Agrippa with, in parentheses, its abbreviation, if an abbreviation exists. Metzius, we see, does not have an abbreviation, so there is no parentheses. What this does is it grabs all of these names, stores them in one JSON file, stores the abbreviations in a separate file, and stores this part of the name in a separate JSON file as well. So I'm going to copy and paste over my praenomina text file, which looks like this when you've copied and pasted them all over. So you've got, looks like 130 different praenomina. Okay, so what this is going to do is it's going to go through, grab all of that, and then it's going to perform all these functions on all these conditionals to separate it out and strip out all the names. And then it's going to store them all as 3 separate JSON files. There's going to be the praenomina, which is going to be all the forms. Then it's going to have the ABS, the abbreviations, and the non-ABS, the non-abbreviations. The reason why we need to keep these separate is going to become a lot more clear in just a little bit. But when we start declining these words, we're going to run into a lot of different problems. Namely, we're going to run into the problem of we don't want to decline a single letter. Abbreviations don't decline. They're just an L and a period. The declination of that word is defined by the preceding nomina. Okay, so we're going to go ahead and just call this function. And again, I'm providing all of these to you on the GitHub page. I really hope you take advantage of them. They're helpful. Get praenomina. We're going to run that, and that's going to go ahead and create for us all of our praenomina data that we need to see. So here's our praenomina in their entire form. So we have the abbreviation with the full name, and then we have the praenomina without any of those, and then we have the praenomina with just the abbreviations. So we have all this, and this is looking like this because this is a Greek character. That's why it has that special character in that look. While this doesn't look clear to us in the JSON file, the machine understands it with that /u code. So that's how we just simply web scrape and grab all of that data. Once you've done that and you've run this script, you don't have to web scrape again. You've got all the data. Now comes the time of manipulating that data to get it to do what we want it to do. Now remember, we're trying to create an entity ruler, and our goal is for the entity ruler to look at a corpus like this and be able to extract Gallia, Belgai, etc. My point is, we wanted to extract all these words, all these nouns, and all their different forms. So we got to make sure that we are able to get these forms recognized. And so the way which we're going to do that, before I move forward, I should specify one thing real fast. I'm going to go ahead and just copy the data for locations into this data subfolder, and then I'll show you what it looks like. So we've got, it's going to be a JSON file just like before, and it looks like this. What I did, I got all of these places. I wrote a simple web scraping script that goes to Latinus Orbis, and I believe, or the Orbis Latinus, which looks like this. A whole bunch of really good data for Latin place names. It has their nominative form. It has their nominative form, various ways in which they're referenced, and their modern day location. The other place where I got some of this data, I believe it's in this data set, I could be wrong, is from this page, which is I just call it Latin place names. It's put out by Rare Books and Manuscripts. It's got a lot of the stuff that the Latin Orbis has, the Orbis Latinus has, but it's got some extra information as well. Really good metadata if you're trying to do something like NER in Latin. So I'm going to slide those out of the way. That's all this JSON file is. And if you're looking at this data, it's not been declined yet. We're going to be declining this as well. So the next step then is to actually start declining all of our data so that we can start cultivating a better data set. What I'm going to do is I'm going to, instead of writing out all the declining rules and everything, I'm going to make a separate script right here so we can get quickly to the actual mechanics of creating NER. So we're going to create we're going to call this declining Latin.py. Why not? And I'm going to copy and paste this whole thing over. So this is a long script, and I'll walk you through it really quickly. So up here, we just import our JSON and glob. That's not going to be entirely necessary here, but go ahead and do it just to follow along. What we have here, though, are 6 different lists. This is going to be for first declension, a second declension, and third declension, so allowing us to actually get all of the different forms that we need to account for in Latin. And then the second declension is going to get us the us, the the a, the e, the o. Third is going to get us the m, the east, the I, the e. And then we got the plurals over here. The plurals we're keeping separate because people, individuals, never have plurals in their names, right? They're not. They do sometimes, but mostly that's not the case. However, places or groups of people are oftentimes going to be in the plural. And this is going to be true for family names too, right? You might be thinking to yourself, to the Julii or whatever, the Julians. They're going to be plural. Well, in that case, the Julians is not functioning as a person tag, rather a group tag. So groups are always going to be plural. And that's what these are for here. So we can keep the first plurals and the second plurals separate. What the functions that come afterwards do is they go through and allow for you to pass in a word, and it automatically figures out, takes a guess based on a set of rules I've developed, what declension that it actually is. And this is going to be the rules for a third declension word, which need to be a little bit different. Here it's going to go through and figure out if it's got an A ending, it's going to be first. If it's got a US ending, it's going to be second. And if it doesn't have any of those, it's probably going to be a third. And the way in which we handle third then gets passed up to the third declension function. And again, if there's a video where you want me to write all these and show you how I wrote them all, more than happy to do that. Just let me know in the comments. And what this function does is it kind of just declines everything for us. And there's a separate function for declining plurals. This is going to be our places specifically. So this is going to look and see if a plural word has an AE ending, if it has an I ending, or if it has an ES ending. And if it doesn't have any of those, it's going to just simply pass. So that's going to be how we handle first, second, and third declension plurals. So it's going to be able to figure out which declension it is based on all these things. Now what we have to do is we need to decline all of those places. So we just simply decline all of the places, list set, get rid of all the duplicates in that line 91. Places.sort simply alphabetizes it, so it's all in alphabetical order. And then we write the declined places to our to a new file, places_declined. We're going to do the same thing with groups. We're going to pass it to the declined plurals. That groups function, remember, is a little different. And then we're going to also do the same thing for our cognomina, the nomina, the praenomina, and the praenomina abs. We're just going to load in because we don't want to decline the abbreviations. And if we look at all right here, all is just a combination of all of these different names. So we got all is equal to cognomina, nomina, praenomina, abs. So it's going to give you all the different names fully declined, listed, so you got rid of all the duplicates to keep that entity ruler really quite small, and then we sort them alphabetically, and then we write them to all names declined. Now, I rushed through that because we're going to be coming back to this script, as you're going to see a few times as we do some kind of experimentation with our entity ruler, and we start to kind of create it. So I'm going to go ahead and run that, and we got a file not found error, data groups. That's because I don't have groups actually introduced yet. So let's make a groups one. Now I told you that groups is going to be manual and a little bit of automation with Wikipedia. So we're going to create a new file called groups.json. And here what we're going to do is we're going to make a few simple guesses. We're going to have an empty JSON list. And we're going to look at our corpus. So I'm going to grab the corpus right here. And I know that Belgae are a group of people. So let's go ahead and separate these two things out. So I've got the corpus on the right, and I got my list over here. So I'm going to copy and paste Belgae, because that's the nominative form, the nominative plural of the Belgae, the people in that region that would become modern-day Belgium, or thereabouts. We've also got the Celti. Cool. And we've also got the Galli, the Gauls, right? So those are 4 groups that we got right off the bat. Now, I'm going to encounter a lot more groups as we go forward. And what we're going to see is we have to kind of figure out how we handle those groups going forward. And we can already see one of the other groups down here, the Helvetii. I'm going to copy and paste them over. This is a tribe that's in Gaul. We're going to paste them there. And we got enough to at least get started. So let's go ahead and run our declining Latin script and take a look at what all of our things look like. Cognomina, I got to change that from cognomen to cognomina. There we go. I think I have everything else correctly listed. Let's go ahead and run it. And now we've got it all declined. So let's take a look at what happened. I think the best way to demonstrate this is with the groups declined. So let's take a look at groups declined next to groups. So here are the groups that we have. And now we've got all of the groups declined. We've got Belgae, Belgas, Belgarum, Belgese. I'm happy with that. Aquitani, Aquitanos, Aquitanorum, Aquitanis, Celti, Celtas, Celtarum, Celtis. Now, is this going to be perfect? There's probably going to be a few things that slip through the cracks and end up incorrect. I'm okay with that. It's going to make mistakes, and that's going to be how I just have to live. It's going to be difficult to create a flawless entity ruler, but that's not what we're after right now. We're after just getting as many possible entities labeled correctly as we can, and then manually kind of correcting them with very minimal work. So with our declined list, we've got our groups declined, we've got places fully declined, we've got praenomina. Where are people? We got people declined somewhere. Groups declined, all names declined. Here we go. Here's all the names declined. We've got the abbreviation of the A. We've got all these different names now in alphabetical order. And we've got a good list now of 12,555 different problems. I want you to pay attention here to this end of this list. We can immediately see that we've got some problems. These are not names. We've made some kind of mistake somewhere, so we need to go ahead and just delete those. And in fact, what we should probably do, since we're doing all this, is going over to the main folder, the cognomina, and getting rid of gens. That's going to be throwing off a lot of things. That's not actually a name. That's a result of poor web scraping. So let's delete those right now. Looks like we have a few of them, so we're going to delete all of those. And now we've gotten rid of those. So crisis averted. We've now successfully gotten rid of one mistake that we see in our nomina, our cognomina. Let's go through and make sure we don't have any other mistakes in the cognomina. Looking pretty good there. I don't see gens anywhere, so I'm happy. I've cleaned up my data set a little bit. Now, again, like I said, if you already want this process done, I've got the cleaned up data sets in the GitHub repo. So let's go back. And let's start kind of trying to figure out how to use what we learned in the past videos now, start really doing the actual work of creating a script now to actually start developing our entity ruler. So what we're going to do is the first thing we have to do is we've got to, I'm going to be copying and pasting these also in from our last video, our last few videos on named entity recognition in general. So we're going to go back to our main.py file now. And I'm going to be copying and pasting in, once again, all of these basic things that you've seen in multiple videos, the stuff that allows for me to essentially write data to a JSON file and load data from a JSON file. We're importing spaCy, spaCy.pipeline, import entity ruler. Again, if you've been following the series, all of these things should be familiar. I'm not going to spend a lot of time going over them. In fact, I'm going to copy and paste in a lot of this data right now and drop it in. And I'll go through and just kind of real quickly go over all of this. We've got a generate ruler function. What this does is it takes in a set of patterns, which we're going to create later in the script with different functions, and it creates an entity ruler for them. This function, create training data, is going to allow for you to create and generate training data in the correct form. So dictionary of patterns for the entity ruler. And this function, the test entity ruler, allows for you to test out the entity ruler. Create training set allows for you to actually create a training set. Again, this is stuff that we've seen in all of the videos prior, so I'm not going to spend a lot of time talking about it. And then it outputs all of that. So what we're going to do first is I'm going to copy and paste in some of this stuff as well. That's going to allow us to simply use these functions. Let's close that. And let's make this all on one screen so it's easier to read. So what we're going to do is we're going to create person patterns, and this is going to take in all of those names declined, and we're going to do the same thing with groups, places. We're going to add all of those patterns together like you've seen in all the videos prior, and we're going to generate the ruler. We're going to call it Latin lock person group, etc. What this is going to do is it's going to allow us to just create a basic entity ruler that will then be used to run over the corpus.txt, and that is going to allow us to then generate a training set. Now down here, I've got this other thing that you probably haven't seen. I've got prodigy equals true. That's going to be coming up in a later video. I'm going to talk about prodigy in depth and how it's part of my NER workflow. For right now, just understand that it needs to be in a different format, and that's why this function looks a little different than what you've seen in the past. It's going to make a lot of sense when we start going forward and start working with Prodigy a lot more in our NER workflows in these videos. But for right now, if we run this script, it'll take just a second to run. We've got a problem. Something wasn't easy to read in JSON. Probably a comma at the end if I had to guess. Which file is it? It's the person patterns file. That's because when I deleted gens, I forgot to delete that little bit there. Now, if we go back, see if I did it somewhere else too. And we've got another problem. What's the problem now? System cannot find the path specified. That's why. I have it saved to a models subfolder, and I didn't have the models subfolder created yet. So that's going to allow us to now have everything work just fine in our models subfolder. We've now got this Latin NER. And again, I had the same problem. I didn't have a training data folder. That was my mistake. So I'm making a folder called training data. And now when I run this, everything should work, I believe, quite smoothly. We'll see in just a second. But if you notice here, I've got the entity ruler created in spaCy based on the rules that I've given it. And I've gotten 374 annotations. So 374 chapters from that first, all the 8 books of Caesar's Gallic Wars. Now, if I want to look at this annotation training set, I can just go down in my training data folder, open it up, And what I've got is a JSON file that's quite large. And we've got one segment of text delineated by double line breaks. So one chapter here, and we've got chapter 1, and we've got all the different entities marked. Gallia, it's marked up as a location, Belgae group, Aquitani group, Celti group. I'm really happy with this. It's going through, and the entity ruler is doing a fairly good job. Rodano, the Rhone, I believe, is what the Rodano is, correctly identified as a location, Belgarum, etc., on down the list. We've got some pretty good entities being found, identified, and extracted. Now, there are going to be some mistakes, and that's what we have to do right now. We've got to go through and look for and find those mistakes. One of the things that I'll kind of save you a little bit of time on and point out are things like Romani, being here most likely referring to the Romans themselves, not an individual person. This is a problem that I need to account for in my data sets. I need to make sure that Romans is included, so the Romani are included in the groups. And that's going to require me to redecline everything. But it also means that I need to probably go back to my my cognomina, find Romanus, and get rid of Romanus. That's going to lead to a lot of false positives, as is Rex. You're going to have, if the word king is capitalized, you're going to have that be Sacerdos, priest, same thing. These are personal names, but they are ones. Oh, and look, there's another problem. Go ahead and start cleaning up this entire list so we can start making sure that the things that are outputted are closer to what we want to see outputted. Now, Vitus might be a problem. Victorus might be a problem. The Victor, because these are also words that aren't just names, but rather Latin words that are used in common sentences to mean things generally. So Benedictus, Benedict, can also mean the blessed, etc. For right now, though, we're going to just kind of leave this as is. However, I do know from past experience and looking through this that there's a lot more tribes, a lot more people referenced in this text than what we've extracted so far. So with that in mind, I need to go through and think about what's going to be in Caesar's text. Well, one of the things I know that's in there is that they mention a whole bunch of tribes. The Belgae and the Aquitani both have large groups of tribes within them. If I go to Wikipedia, I can actually get a really good list. And we see the Helvetii here, the Rauti here. And again, we're not concerned if ethnically if these people are Gauls or not. All we care about is getting the data set cultivated, the data set of names. If I go to the Aquitani, I've got the same thing. I've got a bunch of really good data in the nominative form that I can use. Now, I'm going to copy and paste over the group that I have actually cultivated, the data set I've cultivated, and replace it with our existing one. And I'll show you what it looks like. I believe it's a little sloppier looking than our groups.json. In fact, it is. But I've got a nice set of groups that I've encountered in this text that I think should be referenced, or that I think should be found. So the Teutoni, the Allobroges, and we see that I've copied them, I've got 2 of them here, and that's because I got tired of manually finding them and went to Wikipedia and cultivated this data set. And again, I'm making this available to you. It's on the GitHub repo as well. So what do we do at this stage? Well, it means that it comes time to rerun our decliner. So we have to go back. I'm going to close that, close that, close that, close that. We have to go back to our declining script and rerun it with all these new names. And we should have groups declined now looking a lot larger. And in fact, it is. So now we've got a lot more groups. Now that we have a lot more groups, that means that we have to rerun our pattern creation and our generate ruler and all of that stuff. So we're going to go ahead and rerun that. And we're probably going to see a different number coming out. Instead of 374, we probably will see a little bit more because we might have a few more annotations that are caught. And in fact, we do. But while we see a few more annotation sections added, we've actually got a lot more annotations added. We've already found, and I know this from just counting myself, in a little function I wrote to count all the individuals found, we've got 788 instances of groups found in this text. Now when we go through, we can see that we've got things coming out a lot better. Now remember, we got rid of Romani from people, and now we see Romani being found as a group consistently. That's fantastic. That's what we want to see. Now that we're looking at this data set, we can kind of go through, or this training set, we can go through and take a quick look, just kind of skim through it. We know it's not going to be perfect, all right? I'll show you a perfect example of why it's not going to be perfect. Orgetorix. This is not a Latin name. This is not in our training set, which means, oh, and look, I see another mistake. I see 2 right here. That should not be there. That means one of our nomina JSON files is incorrect. So that means I got to fix that because I do not want 2 being found and labeled as people when I start training a machine learning model. My point in showing you this paragraph, though, is that Orgetorix is missed. That means that when our machine learning model is introduced to this segment and it looks at the entities, it's going to not only not know that Orgetorix is an entity, it's going to learn that it's not an entity. That's a big problem, and that's going to be something that you have to think about and start to introduce changes to your workflow. Now, at this stage, I can do a couple of different things. I can now see that. I can say, okay, I know that that's going to be found in my data set. I want to make sure that he's marked up correctly. And so what I'll do is I'll go down and I'll add it to the nomina. I'll just pick a random place and let my decliner decline that individual's name as well. And so when we run the decliner once again, it's going to be able to actually decline that name now. If I go down to all names declined, it might be at the very end, it might not be. We see I still got that problem there, so I need to get rid of the brackets. Let's find out where there's a bracket. Okay, I got a bracket right there. I got a bracket there. I'm happy with that one, though. That one's supposed to be there. That's my list designator. And I've got that eliminated. Okay, cool. Now when we run it, we should have no more brackets in there at all. Oh, run it one more time. But when we go to groups declined, oh, what is... Oh, I have it under all names declined. Sorry about that. I can't remember the name now. Let's go over here to our corpus. Open it up on the right. All right, cool. And we see we got a problem. The decliner that I wrote out didn't actually work correctly because that's not, I believe, how you decline this individual's name. So that's something that we would have to work into the decliner. I'm not going to do that in this video, but you can already start to see some of the limitations of this method with foreign names. Now, how we get over that is going to come up in a later video when I start introducing you to Prodigy and annotation. But now comes the time for the fun part. Now comes the time to actually open up Prodigy, and we're going to start kind of just doing some basic training with that training data set that we've got. So I'm going to call this something different. I'm going to call it corpus train.json. And I am going to open up Prodigy right now. And I'd like to do all of my training in Prodigy. It's annotation software, but it's built by the same people as spaCy, which is Explosion AI. And one of the things that they are very good at is writing wrappers for spaCy. And so what Prodigy allows for us to do is it allows for us to easily train a model, in my opinion, a little more easily than spaCy, basically just from our training data that we just created. So I'm going to pass in a few arguments. The first one's going to be dbn, which is going to be the function I want to run in Prodigy. And again, I'll have a whole other video on Prodigy and how it works. And for right now, just kind of sit back and relax. I'm going to call it a data set. I'm going to call this Python. Actually, I'm going to call it NER lesson Latin. It's a little verbose. Let's just call it Latin NER 01. And then I'm going to drop in that training set. So I'm going to specify where it's at on my computer. And then basically it's creating a SQL database right now. Not a valid input. And here was the problem. For some reason, it was called .json.json. I've now corrected that. And now when I go over here, it should work just fine. And what I'm doing now is it's creating a database, a SQL database for all of these annotations. Now, in order to train a blank model, I can just call spaCy or Prodigy with the spaCy wrapper real fast. I can say train NER. I'm going to tell it to train the NER01 data set. I'm going to have it make a blank English model. I'm going to tell it how I want it to output. I want it to output to, I'm going to have it output to here. And I'm going to have it output to models. And then we're just going to call this test, Latin test. Why not? That works, Latin test. and that's going to be our Latin test NER. So we're going to go ahead and run this, and what it's going to do is it's going to open up everything. I'll maximize this. Oh, that's created a problem. I'll pause the video now when the training, and I'll pop back when the training's done, because I imagine you don't want to sit here and watch this model train for 5 minutes. Okay, so the model is finished training, and if you look, we have some pretty good precision, recall, and F-score. If you don't know about precision, recall, and F-score, I encourage you to watch my videos on machine learning accuracy and how to measure them. Precision is going to be what we rely on for true positives, recalls for false negatives accurately being identified, and F-score is a combination, or an algorithm to calculate the combination of both of these. And what we're seeing here, for only 380 annotations or collections with annotations, that's pretty good. We're sitting around 90% recall with or precision with location, 88 with the other ones. This is looking pretty good for just experimentation purposes. And now, as we're going to see that this is not a perfect model. It's going to make mistakes. When we see mistakes, it's our job to ask, why are those mistakes occurring, and can I get those out of the model? So what I always do, I don't know if this is necessarily good practice or not. I like to always take my model and test it against the same corpus that I automatically annotated. So let's go ahead down here, and we're going to not use main. We're going to create a temporary function. This is going to be how we testing model.py. This is going to be how we just simply test our model. Again, I'm not explaining this code because if you've been following with this video series, you should know what all this code does. It's going to be in the GitHub. If you want explanations, feel free to drop a comment, and I'll do what I can to help you understand what's going on here. So what I'm going to do is I'm going to close that so we can kind of see it, and I'm going to work with corpus.txt, the same corpus that I used before, and for the model, it should be saved to models, and we see it right here, Latin test. That's our machine learning model. So I'm going to say models./Latin test, and it's going to simply open up corpus and print off annotations and save them to ML results. So let's do that. Let's run it and let it save the results. So it's reading the entire corpus right now, all 8 books, and it's already done. That's pretty good. We're looking at this now, and these are the results. We've got Galia as location. Again, we're expecting amazing results right now. And the reason why we're expecting amazing results is because this is the same data that we used to train it on. And yet we immediately see a problem. Oceano as a person. Now, Oceanus is a Latin name. It is a common name, but the problem is that it's, in this context, being definitely referring to the ocean as in a location. So we need to get that and fix that so our annotations don't come out wrong. We're also seeing 2, location. Now, I don't know what's going on there. My suspicion is if I were to look at my annotation data set, that corpus training, there is probably a 2 somewhere that looks like that. Maybe, I don't know. I don't know why 2 is coming up. My suspicion is that I've overlooked something and that's being flagged for whatever reason, or it could just be a weird coincidence and some bad modeling there on the model's part, some bad guesswork. Romani group, again, this is what we're expecting to see. We want to see good results, but by doing it in this way and by going back and running the model over the stuff that it was trained on, you can easily see if you've got some weird stuff that was worked into the model that shouldn't have been worked in, such as Oceanu. So I'm going through, and it's looking pretty good to me, honestly. I'm seeing some good stuff. And once you start seeing some good results, now we know Oceano is going to be flagged as a person, and we can go back and we can easily fix that. Here, 2 again is being flagged as location. So I'm convinced now that something's happening in my location data that's wrong, that's got a number in it. So if I hit Control F2, again, I'm not seeing anything. So if I go all the way down, I don't see anything there either. So I do not know what's happening and why 2 is being flagged as a location. If you guys are looking at this GitHub repo and you know why, feel free to chime in. This is part of the fun work of working with machine learning, is figuring out why models do what they do. If we keep on going on the list, everything else is looking pretty good. I'm pretty happy with it. And like I said, it should be coming out just right because this was the training data. But let's go ahead and then have some fun and decide to push our model a little bit more. And what I'm going to do is I'm going to copy over another text. This one, the Bellum Civili, the Civil War. from Caesar. Now, this is not a difficult test because it is a text written by the same author. It's a text that is structured in the same way. We would expect it to do somewhat well on it, right? So let's run our testing model function again, except this time over the bellum civ.txt that I just copied in. So all of the Civil War. Let's run it. And if we run it, it's going to paste all the results to the ML_results. And like I said, you're seeing that 2 flagged as location. The model just learned something really weird. I'm not really sure what it is. But what we're seeing is C, Caesar, L. We're seeing good stuff. All these are people. Scipio, and that's being flagged as a person. Thought I was going to have to work that into the model because an earlier version of this, Scipio, wasn't identified correctly because it never encountered Scipio before, but for whatever reason, Scipionus with an earlier test model was coming up wrong. I thought I was going to have to show you how to fix that in this video, but I'm not going to have to because it came up right. Sola, person, again, never encountered Sola. This is looking good. This is indications that our model has learned to generalize. AGI, it's learning what locations are. It's learning what people are. That's looking really good to me. Actually, this model is much better than I thought it was going to be. And that means that I'm not going to have a lot of stuff to kind of show you with problems to encounter in this video, like I kind of had hoped. Anconam, I'm not really sure what Anconam is. Is it a location? Ancona, it is. It's a city in Italy. So good, that's a location. And again, I'm just on another screen checking some of these results. And I don't claim to be an expert in all Latin locations. So, you know, I check Google, check Latin dictionaries, find things out. You'll see certain things being flagged incorrectly, like recepto here, I imagine, is just a capitalized word at the start of a sentence. So we can easily go to our bellum civ file and type in recepto. And recepto, sure enough, right there, recepto, fermo, expulsia. Is recepto there a person? Is receptus a person's name? I don't know. I can go up and use my handy dandy cheat sheet here. Whitaker's words, and it's looking like it's not ever a person. So I'm not really sure what's going on there or why fermo is capitalized. Somebody can feel free to explain that sentence if they wish. But anyways, I'm going down the list. I'm just kind of manually checking things. And this is what you should be doing. Each time you train a model, throw it against something easy, throw it against something a little bit more challenging. And then, for really a lot of fun, give it something that's completely different. Just like, is it Flying Circus, and now for something completely different? So what I'm going to do is I'm going to give it something that's more challenging. I'm going to give it Livy. So I've got the first book of Livy now copied in. Here it is right here. I'm going to test the model against Livy 01. Again, this is another step in challenging. It's a different kind of text written now by a different author. So this is a little bit more of a challenge. I want to see what the results are like. And what we're going to see at the end of all of this is I'm going to give it something that is really challenging, which is something from medieval Latin, and test it on that. ML results. Okay, so we've got Troia being, this is, and I believe in this context, Troia, actually in all contexts, is Troy, the place. I'm not going to even pretend to be able to pronounce that. Paphlagonia. That is in fact a location. Definitely out of scope for this model. Definitely learned to generalize. Trojani. Never met the Trojans in any of the training data. Yet it's found them and identified them correctly as Trojans. This is looking pretty good. I'm pretty happy with it. I am now more convinced than ever that I've got something wrong in one of my data sets, because once again, it's grabbing this this bracket in groups. So if I go to groups declined and I scroll down, maybe the model is just acting funky. I don't know. I can't figure out why it's doing that. Let me go back to those ML results though, so I can keep on going through them. ML results. Enter. This is not a person at all. This is going to be an actual, just normal word, right? If we keep on going on the list, one of the things I expect that we're going to see is an error with induce in the form of ende. But again, I'm going through and I'm seeing a lot of pretty good stuff for very minimal training data. If we go down and we look for end, I don't have induce being populated. That's one of the things I expected to see. It flag is wrong. Sabinos is a group. Romanus is Tullus person. Like I said, all this is looking pretty good. We're getting some definite mistakes, but it's a machine learning model. that's sitting at, I think, 90% accuracy overall. I don't expect this to be perfect, but for just quick experimentation, this isn't bad. This tells me not that my model is great, but it tells me that I'm on the right track. And this tells me that if I gather more training data from a broader sample, right now this is trained on one text. If I give it training data from maybe another text of Caesar's, uh, uh, maybe some Livy, I got something that could possibly be quite good here. And I need to get rid of things like enter from my location training data sets. So let's go ahead now and just kind of start exploring different really out of scope Latin data. I'm talking medieval Latin. And in another video, I'm going to show you why this fails and how to address it if you're a medievalist like me, because medieval names do not play by the same rules as Latin names. I'm going to give it Berengar, early medieval text, and we're going to look at the ML results. Scrolling up. All right, so I'm going to pull up the text on the right over here, and we're going to compare that with the ML results. So we're going to go through and look. I expect to see a lot of errors here, and in fact, we do. Now, why are we seeing a lot of errors? So Petrum, this is Peter. This is not a group. This is a person. Berengarius, it's correctly identified as a person. Bernardi, this is not a group. It's a person. Why are we seeing errors like this? Well, Cuius, definitely not a person. Filius, in that context, it might be referring to Jesus, so I'll accept that. But Grande, not a person. Well, Golly comes up as a location. Anyways, but what we're seeing here are explainable mistakes if we understand how our model was trained. Our model was given nothing but classical Latin. Classical Latin, it differs dramatically in syntax and structure, in word usage, in the way certain words are declined. All these things are very different. It's a different beast. While it's the same language, it's from a completely different era of that language. And for this reason, you need to have either a model trained on both medieval Latin texts and classical Latin texts to have a good model that can work with both, or you have to have a model that was given that just classical and it only runs on classical, and have a separate one for medieval and it only runs on medieval texts in order to have much better models. And I would encourage the pursuit of both of those. So Petro didn't come up, Petrus didn't come up in any of our training data. Don't expect it to be identified correctly all the time, but you see that it's flagged as a person occasionally as well. So groups and person is a difficult thing for a model to distinguish. Remember, our model, it exists in a single pipe in the spaCy model. It's not receiving any data like parts of speech, proper nouns, etc. It's not being given any of that. And so the model is having to make deductions based on a highly inflected language, and it's only got a small amount of those words that are even declined in all the different ways in its vocabulary, and it's having to make decisions. And if we think about the way we refer to groups of people and persons, it's rather similar, right? While the word might be plural, the way in which you talk about a person and people will have similar words in similar contexts. So the struggling between group and person here is understandable, especially with a text that is as foreign as a medieval text. However, what we have now is something that is good. Not great, but something that is good we were able to make in a very limited amount of time that can actually work on a highly inflected language with very, very minimal training data. So what are the next steps after this? Well, further testing, further structured testing when you run the model against a pre-annotated text and then actually have concrete numbers of how well it performs. The other thing that's necessary, getting more training data, doing these steps with more texts. So doing these steps with Livy, doing these steps with the Civil War text, throw some medieval text in there, Berengar, and make adjustments to your annotations and your training data as necessary, so that the model starts to learn not just one author's style of writing, but is exposed to an entire language and all the different genres, all the different styles. But even still, you can see the potential of this with a model that was given very little training data. I know this was a video that's longer than my normal videos, and I hope that you found it interesting. You've seen the start of the problem and kind of the overall way I kind of progressed and worked through that problem. I know I didn't spend a lot of time talking about the code. If you want to see videos on the code in more depth, more than happy to do that, but I wanted to emphasize conceptually how we solve a NER domain-specific problem for an inflected language like Latin. If you understand that at least rudimentarily, then I've done my job. In future videos, I'm going to start working with medieval Latin and show you how we can acquire medieval Latin data, where we can get it. I'm looking at you, the prosopography of Anglo-Saxon England, one of my favorite digital projects, and how we can use that data that we have for medieval texts to generate better training sets on medieval texts to then have better medieval NER models. That's going to be it for this video, though. Thank you for listening.